So first of all, we are having a question here. We have to check if the given equation, set of equation, it's consistent or not, and if it is consistent, we have to find the solution. So these are the two equations given. So then we have to find the A matrix. So x variable, we have to find out the coefficients here. X variable coefficients will be here and y variable coefficients will be here. So it will be 1 and 2 for x and 3 and 6 for y. Then B matrix, it will be the solution matrix, 5 and 9. Then X matrix, it will be for the variables x and y. So now we have to solve this equation. So first of all, what we have to do means we have to find the determinant of the A matrix. So when we are finding the determinant, first multiplying the primary diagonal 6 into 1 minus the other diagonal 3 into 2. So it will be 6 minus 6, it will be 0. So when the answer is 0, we know that the given set of equations, they do not have unique solution. They can have either no solution or many solution. So to confirm this, what we are doing means we have to check the next step, which is to find adjoint of A multiplied with the B matrix. So to find adjoint for a 2 by 2 matrix, we are having this technique, adjoint of A. So what we have to do means the primary diagonal, you have to just switch the places of the elements. So it will be 6 here and 1 here, and the other two elements you have to just change the signs. So minus 3 and minus 2. Then with this we are multiplying the B matrix, which is 5 times 5 and 9, right? So when you do the multiplication, it will be 6 into 5, 30, plus minus 3 into 9. So it will be minus 27. Then next row, so minus 2 into 5, it will be minus 10, and plus 9 into 1, it will be 9. So if you do the calculations, it will be minus 3 and minus 1 here. So as the given matrix, it's not a zero matrix, right? It is not equal to a zero matrix. And when the given when we are getting adjoint A times B not equal to the zero matrix, it has no solution. That means the given set of equations, it is inconsistent. So now we are having another equation. Two equations are given, and from this we are finding the A matrix 2, 3 and 5, 2, and the B matrix with the solutions 1 and 7, and the X matrix with the variables x and y. So first of all, when we are starting to solve, we have to first find the determinant of the A matrix. So if you find the determinant, it will be like the primary diagonals you have to multiply. 2 into 2, it will be 4 minus the other diagonal 5 into 3, it will be 15. So 4 minus 15, it will be minus 11. So this is not equal to 0. As it is not equal to 0, we can say that it has an unique solution. So now we can proceed with the equation x is equal to A inverse times B, and for that we need to find out A inverse. So A inverse is this equation. It is equal to 1 over determinant of A multiplied with adjoint A. So for this, we already have the determinant of A. It will be 1 over minus 11 multiplied with the adjoint of A. So for the adjoint, we have to just switch the places of the primary diagonal elements for a 2 by 2 matrix. So 2 will come, this 2 will go here and this 2 will come here. So it's actually the same itself. And the other two elements, it will be minus 5 and minus 3. Now this is our A inverse, and what we have to do means we have to multiply the A inverse with the B matrix to find out the X matrix. So 1 by minus 11 multiplied with 2 minus 5, minus 3 and 2, and this is multiplied with B matrix 1 and 7. So we'll just multiply the matrices first and then do the other part. Let the minus 11, 1 over minus 11 be outside itself. So 2 into 1 minus 5 into 7. So 2 ones are 2 and 5 sevens are 35. So minus 35 because there's a minus sign in between. Then minus 3 into 1 it will be minus 3. Then 2 into 7 it will be plus 14. So 2 minus 35 it will be minus 33. And 14 minus 3 it will be 11. But we are having minus 11 outside, so we have to divide both the terms by minus 11 in the matrix. So minus 33 by minus 11 it will be 3, and 11 by minus 11 it will be minus 1. Now what we have to do means we are comparing the X matrix with this matrix which we have found out. So the X matrix is XY. So when you check, you have to just equate the corresponding elements. So X it will be equal to 3 and Y it will be equal to minus 1. So this equation is consistent, and after that we have solved these set of equations and found out the answer to be X equal 3 and Y equal minus 1. Now we are having a 3 variable equation set. So there are 3 different equations. So from these equations we can find out the A matrix, B matrix and X matrix. So as usual the same steps apply here. First we have to find out the determinant of A matrix. So when we find the determinant, it is not equal to 0, it is equal to 9. So it has a unique solution. So then what we can do means we can proceed with the equation X is equal to A inverse times B. So for A inverse, we have to first find it like this: 1 by determinant of A times adjoint of A. So if you check, for adjoint of A, what we need means first we have to find out the cofactor matrix. So cofactor matrix is actually very simple to build. So first element of the cofactor matrix means what we have to do means cancel out that row and column. Then you have to find out the determinant of the left out elements. So 1 times 1 minus 3 times minus 2. So 1 minus minus 6, it will be 1 plus 6, so 7. So when you check the elements, these elements you have to multiply by minus 1 also. So finally you'll be getting these elements as the answer: 3, 3, minus 3 and minus 3 here also. Then after finding the cofactor, what we have to do means you have to find the adjoint of that. So adjoint, what we have to do means just take the transpose of the cofactor matrix which we found out. So when you do the transpose, it will be this matrix. Transpose means changing the rows into the columns. So 7, 3 minus 1, it's in the first row, so it becomes in the first column. Then after that, after finding the adjoint of the A matrix, then we can proceed with the equation X is equal to A inverse B. So instead of A inverse, we can put 1 by determinant of A times adjoint A. 1 by 9, determinant of A is 9 and adjoint A we found out. Then with that we have to multiply the B matrix as per the equation. Then if you do the multiplication, finally you will arrive at this answer for the X matrix. So X matrix, it's equal to X, Y and Z. So the first element should be equal to the first, so X equal 1, second one is Y, that should be equal to 2, and third one is Z, it should be equal to 3. Like that you can solve for a 3 variable equations also through matrices.